Hi, and welcome back to the Rice Museum. I want to talk to you today from inside the Minerals Science and Industry room. And what I like to do when I show people this room is start with this giant silicon ingot. This is one of the older style when we had the giant ingots to make technology. This will eventually become a computer chip, and I'll show you how. Imagine you start with pure silica beach sand up here, then you heat this up to 1400 degrees, and what you are doing is you're creating a silicon crystal. And it has to be perfect so that the zeros and the ones don't get lost inside the crystal lattice. Then you take it over here and you slice it into wafers. And then over here it gets etched and it gets printed. And then on the very end, then we cut it into little tiny, the little chips, if you will. So that's how you go from beach sand all the way to the chips that go inside your electronic devices. And it's really important to understand the underpinnings of modern technology is geology, because there are over 80 different elements in your handheld device, and those have to come from somewhere. We can't just recycle them. So I like to explain all that when I tell people about this room. We've got a bunch of other exhibits I want to cover while I'm in here. On this side, we show how natural crystals grow from individual atoms that attach to each other. And we've got examples of synthetic bismuth. We've got quartz crystals that were grown in a lab, and other lab-grown minerals, just to show you that we can grow these crystals in the lab. It's just extremely expensive. Okay, then we come over here to the uses of minerals, and this is really important so that you understand that a lot of the things you take for granted actually had to start from a mine or a natural deposit somewhere. This gypsum crystal could eventually become the drywall in your walls, or a soil conditioner, or a fertilizer. Crest toothpaste has fluoride in it, which comes from fluoride deposits. You've got the sulfur that goes into road flares. Tums have calcite in them. We use sphalerite to get zinc, which we use for our plumbing, our pipes, as well. Now we don't use so much lead. Pyrite produces sulfuric acid, which has a lot of industrial uses. Hematite for magnets. Azurite is for tinting. Copper goes into copper pipes and copper wires. Galena is the source for the lead that goes into batteries, especially the old style batteries before lithium ion. We've got examples of halite for table salt, zeolites for water conditioners, barite for paper and linoleum. There are just a lot of things that you may not have thought about, so I really enjoy this display to show that there's a natural sciences and a geology component to a lot of everyday things. So the next display over here will roll you through some of the common ways that we tell one mineral from another. We might describe their crystal habit, and there are a bunch of different forms up here, from druzy and ram's horn crystals. We've got hematite in a botryoidal form. We've got perfect cubes of pyrite from Spain. So you can see there's a bunch of different habits. And then we've got a few crystals down here, the fibrous chrysotile asbestos. We've got down on the next layer the hardness scale. The easiest way to start keying out a mineral is to use its hardness from 0 to 10, with talc being at the bottom, which you can scratch with your fingernail, all the way up through diamond at 10. And there are different minerals that define these numbers. So you can have your own kit at home for a hardness kit, and you can use things like your fingernail, you can use a nail, a copper penny, a plate of glass, and you can use those to help key out what you're looking at. And then some of the crystal habits, the cleavage is another way how a crystal breaks across a crystal plane, if it's flat and platy, or if it's cubic, or if it's orthorhombic, rhombohedral like a calcite. There's color in this next display. You can see purples and blues and yellows, greens and oranges, and a lot of those are just classic for minerals. It's an easy way for your eye to help you figure out what you're looking at when you're out in the field. Another one is luster. Some really cool names for some of these lusters. Adamantine for just a brilliant luster. You're trying to describe how that crystal looks to the naked eye. So earthy for kaolinite, greasy for a talc because it feels greasy. Calcite is kind of pearly. You got silky, vitreous, resinous. There are actually a lot of different terms, and it's really hard to get, it's not a numerical scale, right? So there's no known break-off between silky and vitreous. But after you get familiar with the minerals, it becomes a little bit easier. Another one that you can do is streak, and usually you have a little piece of porcelain tile and you rub the mineral on it, and then you see that color, and it will tell you if you're, like goethite has a kind of a brownish yellow. Pyrite will leave a gray, but you can smell the sulfur when you do it. Classic one is hematite, which when it's really polished it will look kind of like metallic gray, but it will leave a characteristic brown streak. So some of those are pretty interesting, and you get used to it after a while. And in a pinch, I have turned over the lid on my toilet and used the bottom of the rough porcelain on the back of the rim for a streak test. So even if you don't have your own tile. Density is another one. It's not really easy to determine it. You can put it in water and see how much the water raises if you have it in an exact cubic centimeter format. Another way to do it is what we call a heft test, where you just kind of put a sample in your hand and you just kind of give it a little pull up and you just feel how much gravity is there. It's not obviously real accurate, but it can give you an idea. And follow me over here to the other side of the room, and we've got a little bit more crystallography over here. Talk about native elements. Not every mineral that you see out there is, like silicon is SiO4 with 1 silicon and 4 oxygen atoms. A lot of times in nature you will get a pure form of an element. So gold, for example, is just Au. Let's see, another one would be diamond, which is just a C for carbon. Sulfur, which I showed you over there, is just an S for sulfur. So, but more often than not, you get sulfides, which has a little sulfur in it, oxides, which is a little oxygen, silicates, sulfates, carbonates, hydroxides, halides if it's salty, phosphates if it has phosphorus. You can even have tungstates if you have a little tungsten in there, or borates with some boron. So a lot of different minerals form out in the wild, and we have a really good display here that just rolls you through what you're looking at. And then finally over here we get into the real science of mineralogy, and we talk about nesosilicates, sorosilicates, and a lot of this is above the heads of the third graders that come through. But it's important for us to show you what these silicates are doing. Are they rings? Are they tetrahedrons? Are they forming single chains, double chains? And it helps you to kind of visualize what's going on at a molecular level inside these crystal lattices. And then we've got really good examples of the pyroxenes and glaucophane schist, some augite from the Oregon coast, and then we've got some sheet minerals down here. So a lot of people pass by this room too quickly. I like to encourage people to come in and really understand the science of mineralogy, how to tell different minerals apart. There's just some really cool science in this room, and we've got some great ideas for the future to blow this exhibit out a little bit more on careers in the geological sciences. So come back soon and we'll have more information for you. Thanks for listening.